Welcome to day 2 of ARCOM 2021. I'm Colin Booth. As you may have heard from our conversation, I was having internet problems yesterday, so I'm reluctant to turn my camera on, but I'll certainly paint the picture of you. I'm how would you describe me, Emmanuel? I suppose a gentleman of years,
yes,
with grey hair and a grey beard.
I was going to say the wisdom beard.
Yeah, wisdom. Well, possibly. Still lots of space to learn. Let's say that.
That's why we're here.
Maybe some wisdom. And my colleague in the room is Emmanuel. Would you like to introduce yourself, Emmanuel?
Right. I'm Emmanuel Aboagye-Nimo, and I'm going to be supporting Colin, so you can see me because my internet is quite stable. And if at any point in time Colin should drop off, I will be taking over. And also, I'll be looking out for any questions in the chat. So if you don't want to speak up in the end, I'm happy to read out your questions.
Okay, super. Thank you for that. Okay, so day 2 of ARCOM. This is session 4, room D. So hopefully everybody's expecting that. So the focus of the session is on-site construction. We've got 3 papers for you this morning. The first of those is focusing on improving industrialized house building. The second is on design and construction of a Chinese public services building, which is a longitudinal study across several months. And the third one is focused on the affordance of remote working in construction. Our first paper then is going to be presented by Wolfgang and Manfred, who are both from Vienna in Austria. And without further ado, we will press play.
Welcome to my presentation with the topic Disclosing Improvement Potentials on Construction Sites in Industrialized House Building. My name is Wolfgang Grenzfurtner and I am pre-doc researcher at the University of Natural Resources and Life Science Vienna. The research I'm going to present is joint work with Manfred Gronalt. The object of our investigation are the methods used in continuous improvement programs to improve on-site performance in industrialized house building. As you might know, an industrialized building is made of prefabricated story-high wall elements or modules and prefabricated ceiling and roof elements, which are manufactured within a plant and assembled on construction site. On this figure, you see a representative order fulfillment process in industrialized house building, with various sub-processes and activities in sales, design, offsite and on-site production. During our research, we focused on the on-site part of the production. It is often argued that improving performance of on-site processes with site assembly and interior construction is much more difficult as for the other parts of the industrialized house building order fulfillment process. When analyzing the current literature, you may identify that there is already missing an investigation that addresses the dissemination of methods for identifying and realizing potential for improvement within construction site processes. Such an investigation may help practitioners and scientists to better understand needs to further develop continuous improvement programs within industrialized house building and may help to find solutions for relevant weaknesses in identifying and analyzing improvement potential. For this reason, our study aims to analyze the methods and tools used in industrialized house building continuous improvement programs. Weaknesses in current continuous improvement practices, as well as best practice cases, need to be identified and evaluated. To work on this topic, we conducted a multiple case study within the industrialized house building sector. To select cases, we did a qualitative analysis of corporate philosophies provided by the 3 national trade agencies from Austria, Germany and Switzerland, and selected 8 representative cases out of a pool of 76 companies. With representatives of selected companies, semi-structured face-to-face interviews were conducted. Therefore, an interview guide with 11 main questions was applied. Answers were protocoled by 2 researchers during the interviews. The analysis of interview protocols was done by using the method of thematic coding and content analysis. This slide and the following show our preliminary findings. An overview of the tools and methods applied for the identification of improvement potential and the analysis of improvement suggestions within the field of quality is illustrated here. The analysis shows that most cases use qualitative feedback methods to identify improvement potential. Cases 2, 3, 4, 7 and 8 implemented an improvement scheme to receive feedback from site workers on quality issues. Additionally, cases 3 and 7 systematically apply quality cycles and feedback meetings to collect qualitative feedback on problems from site production. Informal feedback from site workers was found to be an important source for identifying improvement potential. Nevertheless, interesting cases were identified that use measurable indicators to identify potential for improvement in the area of quality. Cases 4 and 6 implemented measurable quality parameters such as sonic measurement or blower-door tests to benchmark their on-site teams, aiming to identify specific knowledge of best-performing teams. This approach helps to lift tacit knowledge and use it in a systematical way to train other teams and to improve processes. A further approach using an analysis of quality costs for failure categories was used by case 5 and was in its implementation phase by case 1. Both cases belong to bigger companies within the case study and are probably not able to handle the potential amount of qualitative feedback on quality issues in a systematic way. For the analysis of improvement proposals to be tested, no quality indicators are used by any company except those related to sonic measurements and air permeability. In this case, mainly qualitative feedback is used where the observation of construction site processes by R&D staff is of particular importance. An overview of the tools and methods used to receive feedback on improvement potential in the area of productivity and to analyze improvement potential is given on this slide. Target actual comparisons of working time are common indicators to identify negative deviations from the plan. Thus, systematic problems can be identified more easily. Usually, a combination of qualitative feedback and the indicators is used to narrow down the problems and their causes. However, the application of target actual comparisons to identify specific tacit knowledge of on-site teams is just implemented from case 7. The identified knowledge is used for training of other site teams and for process improvements. The analysis of improvement suggestions relies in most cases on a combination of REFA, time studies, and qualitative feedback from site observations, feedback meetings, and informal feedback. However, cases 3, 7, and 7, which produce highly customized building, and case 6, which serves a short on-site realization period to customers, rely on qualitative feedback. Finally, we conclude that companies mainly use experience-based methods for identifying and analyzing potential for improvement in the field of quality. Due to complexity of quality problems arising on construction sites and the missing abilities to systematically measure and assess quality, companies prefer the use experience-based methods. Best practice cases were found in the use of measurable quality parameters to identify tacit knowledge of best performing teams, and in the application of quality cost analysis to systematically identify and reduce costly problems. To improve productivity, indicators such as target actual comparisons of working time are of high importance, which are usually combined with qualitative feedback from construction sites to narrow down the problems and their causes. An exception are companies with a highly customized product which mainly rely on qualitative feedback and do not use indicators. Thank you very much for your attention.
Okay, thank you very much, Wolfgang, for your presentation. I have some questions of my own, but first of all, I'll just offer opportunities to delegates in the room. Has anybody got a question they would like to ask? They can either put the question in the chat, or if not, raise your hand, please.
Colin, can I jump the queue while we're waiting?
Oh, go on then, certainly.
Okay, so Wolfgang, this is a really interesting work, and I enjoyed it very much. So thank you for that. Now, one of the things that we used to do some projects with some of the big construction firms in the country for student projects. And one of the key problems that we all admit happens is that we've got lots of different factions in UK construction industry. And so there are small subcontractors who work in these firms. Now, the problem is they don't share a common goal. As much as we want to say they all want to get their project complete, everybody's trying to focus on their own tasks. And for that reason, disclosing their improvement potentials, they feel like they will lose their competitive advantage for the future. Particularly when things are transferred through tacit knowledge, they wouldn't want to pass it on to let other people know how things are going on in their own small unit. How do we overcome that, the competitive advantage problem? Oh, sorry, I think.
Do I need to allow?
Yes, I've done that, sorry.
Okay.
Good morning.
Good morning.
Good morning, Wolfgang. Apologies, we had you on mute for a moment then.
Thank you very much for your thoughts, Emmanuel.
Yeah.
Yes, I see, especially this part with the supply importance of the supply chain in construction is definitely of importance. And the study which we presented here was not just focused on the continuous improvement part. It was a bit bigger study where we also focused on performance measurement and management on construction site in industrialized house building. And we are this is a thing where we are currently working on, is that we are also focusing on the sharing of performance measurement data and knowledge within the supply chain. And it was very interesting for us that there is data shared, but mainly with side forms and so on in the field of quality. But the biggest problem, more or less, is that especially performance or productivity data isn't really shared, and it is sometimes difficult to improve the overall order fulfillment process. As you mentioned, there are different goals of all the companies inside, but the industrialized house building industry is a bit different, maybe, and there are from other industries, especially in Austria, Germany, and Switzerland, and I also know it from Sweden, that there are much more long-term contracts within the industry, which helps to develop goals for the whole supply chain. These are our thoughts on, or our ideas on this, and our preliminary findings on this part of the work, which isn't included in this paper, but it's very interesting, of course.
Now, thank you very much. You point out the key problem that a lot of people are scared of in the UK, which would be the long-term projects. They're not sure of it. So it's the job security that makes people try not to share the information. But if these ones are long-term, then people are happy to, progress and move on. Thank you very much.
Thank you.
Okay, I can't see any questions in the chat, so I'm going to jump in with my own then.
Sure.
So obviously I've seen your presentation, I've looked through your paper, and one of the things I haven't seen is anything about the profiles of the organizations themselves. Given that companies can themselves demonstrate a commitment to continuous improvement in many ways, such as adopting ISO plan, do, check, act approach to how they run an organization, how many of the organization profiles in this study have got anything such as ISO 14001, an EMS, or ISO 50001 energy management? How many have got those types of certification or anything similar to demonstrate their commitment to continuous improvement?
We didn't check that. Thank you for this question. We didn't have this part directly within our interview guide in order to receive feedback if they are using certifications for quality management, more or less. So especially for the ISO standards, we haven't really checked it. But during our interviews, we received feedback from, for example, from case 6, that they have a certificate. And I know that there are companies as case 1, which is a company where we have an ongoing project with, that they had this certification in the 90s but didn't proceed with it. And it would be an interesting topic to also include it in a journal paper. Thank you very much for this feedback. Maybe we can get this information from the companies. Thank you very much.
Yeah, certainly. No, I think it'd be useful if you're going to present this for a journal. Then certainly the profile of the organisations will be clearly important for the readership. Okay, one final question then. So, well, I suppose there's two parts really. Out of the pool of 76 companies you chose, out of the pool of 76 companies, you chose 8 case studies. I just wonder if you can elaborate on your selection process, and at the same time, if you can explain why these 3 particular countries were chosen.
We maybe in the beginning we did these sector analysis where we looked at the some criteria, as for example we classified the production system of the companies according to the degree of the product standardization used, and also the construction methods, more or less, or amount of offsite construction. Therefore, we used the production classification matrix von Johnson and Rudberg. Furthermore, we also analyzed which are the main clients. Are these business clients or private clients, or a combination, as there are differences in handling the on-site production. As you might know, a private client in a lot of cases do not have an on-site manager, which is just done by the company, IHB company itself. And we also looked at the volume of buildings produced from the companies, and then also we looked at the strategic focus, if they are having a cost leadership strategy or a diversification strategy, and looked especially if there are different diversification strategies. And we used this for these sector analysis to identify which in which directions the sector is more or less diversified, and selected cases which fit best, or that we could have cases from every or to each criteria's Ausprägung. I don't know the English term. So that we have, for example, one for cost leadership and for diversification, and for the different cases in diversification, and also for the standardization. We had customized standardization, we had tailored customization, and so on. And that we rebuilt more or less with these 8 cases the sector itself. And the cases are more or less different from their criteria or these criteria. Yeah.
Okay. And the second part of that question was, and if you could just do it quite briefly, because I know we're probably at our limit of time, is the rationale for the choosing these 3 particular countries?
The rationale for choosing these particular countries, we also thought that we could include Sweden, which wasn't possible because they have no national trade union for industrialized house building, and in Austria, in Switzerland, and in Germany, there are these organizations which provided the data for us. We know that there is also an organization in Italy, but we had this language problem. Nobody of our research team speaks Italian, so this was also one thing why we focused on these 3 German-speaking countries.
Okay, well, thank you for your honesty in your answer.
Thank you so much.
So, thank you for your presentation. Thank you for your paper, and we'll let you step down now, and we'll move on to our second presentation, which is going to be presented by Kizu et al. They come from China, UCL, and University of Bath, the authorship. So we'll move on to the second paper.
Good morning, ladies and gentlemen. My name is Zhuke, and I come from Southeast University. It's my great honor to make the keynote speech at this conference. My paper type is the design and construction of public service building in developing rural regions during the post-COVID-19 period based on the Chinese Village Center. This presentation will follow a sequential structure as background, method, and the results and discussion. This research starts with the background research of rural construction. The findings indicated 3 most popular themes, including heritage preservation, sustainability improvement, disaster reconstruction. COVID-19's rapid expansion and extreme high transmission rate have triggered an urgent demand for medical space. As pointed out by the report of the World Health Organization, the developing area is facing a growing threat because of the scarce medical resource. Current solutions aim at establishing treatment space within a short period, relying on modern construction equipment and skilled laborers. While this approach would not be effective in less developed regions because of the weak industrial fundamental. Although the adequate workforce used to be an alternative in rural regions, the social distance constraint of COVID-19 has prevented delivering projects rapidly with such a labor-intensive construction approach. Therefore, there has been an urgent need of developing adaptive industrial construction methods for these places. By indicating the gaps above, this study proposed an adaptive industrial construction method appropriate for less developed rural areas, which fulfills the requirement for both high efficiency and a low labor density. A case study of a village center was deployed to test the effectiveness of the proposed method. This project was located in Jiangsu Province, China. It is a 2-story residential service center with an area of 574.44 square meters. The construction process from December 2019 to January 2021 is recorded and compared with the conventional approach. Adaptive construction methods were used in the foundation and structure. This project integrates the approach of roadbed construction as illustrated in the technique drawings, as no masonry or reinforcement foundation is needed. To save the time for masonry foundation or formwork, reinforcement construction, and concrete curing. The structure is similar to a masonry one, in which the load-bearing walls works as enclosure components, resulting in the less construction time of the enveloped structure by using staircases, large blocks, and the shop grade. The construction process from December 2019 to January 2021 is recorded and compared with the conventional approach. The effect and advantage of integrated technology were studied through the comparative analysis of data collected during the project and the simulated data. Discrete event simulation was adopted in this section for its ability to capture interaction and interdependence among complex construction processes. The outcomes showed that it effectively decreased the labor density and construction quantity and proved it practical in the COVID-19 environment implementation. The construction schedule directly compares the construction with the proposed approach and two limited conventional approaches. The process was divided into 5 categories: foundation, reinforcement, masonry, formwork, pouring, and cladding, each taking a role in a graph with a unit color and corresponding labor amount. The figure shows that the conventional approach had to employ 5 to 10 more laborers in masonry assembly and about 4 more laborers in cladding if required to finish the project within the same period, but less workforce needed for formwork assembly and pouring because the conventional structure consists of less constructional columns. Theoretically, it needed to employ 133 laborers for foundation construction and cladding, respectively, to fill the need. However, these numbers were meaningless in practice, indicating no possibility of matching the proposed schedule by conventional construction. The second value that controls the number of personnel compares the difference in construction period. With the same level workforce amount, the 5 projects took 143, 12, 41, 36, and 33 days, respectively. The whole process would last for approximately 178 days, which was 129 days more than actual. In summary, the construction quantity reduction in foundation construction, masonry assembly, and cladding indicated a significantly advantage of industrial construction in rural area. Third type controls the value of the construction period and compares the difference in personnel density. Figure is the line graph of distribution with time. In general, the labor density was lower when employing the proposed approach. The most significant difference was observed in the first 6 days, during which 11 more laborers were employed in masonry assembly by the conventional approach. The maximum value of the proposed approach was 1.57 on the 12th day. That of the conventional approach is 2.55 appeared on the 6th day when 20 workers worked at the same place. With a threshold of 0.6, it was observed that both values distributed at a safety level at most time. However, the line of the conventional approach was closer to 0 than that of the proposed approach, which indicated a smaller range of labor management in conventional construction. Its weakness was magnified when setting the threat to the 0.32. The conventional approach was higher than the requirement for about half of the time, while that of the proposed approach remained below. It means that a 2 meters social distance is harder to keep by conventional construction than the proposed method. We can now draw a conclusion that with the relative low level
Okay, thank you very much for your presentation. As before, I'll first of all offer the delegates in the room the opportunity to ask questions first. So if anyone would like to raise their hand, and I'll just give you opportunity to appear to be able to answer questions yourself. Are you still there? I've just tried to give you presenter access.
Yes, Professor.
Okay, great. We can hear you.
I want. I want to welcome one of our author, Yiming Xiang from UCL to answer the question because my English presentation.
Okay, so which colleague would like me to answer the questions?
Yiming Xiang.
Okay.
The second author of this paper.
I think I've selected the right one.
Yeah.
Just check I'm choosing the right person. It was Jaijing. Was that the one?
Yiming.
Oh, YI, sorry.
Yeah.
Just scrolling down. Okay, sorry. Oh no, this person's in Frankfurt. Is that the one? Can you spell the name of the person for me? Sorry.
Yimingxian.
Okay. Yeah, that's the name I've got. It says they're in Frankfurt in Germany.
Hi, Colin.
Hi. Good morning.
Good morning.
So, your colleague has kindly thrown the baton to yourself to answer the questions. Are you okay with doing that?
Yeah.
Okay. So let's have a quick look in the chat then. Has anybody yet put any questions in? So no questions in. So in that case then, I've got a couple of questions. And the first one is, I've looked at your paper, I've seen your presentation, and I just wonder, do you think there's anything that's unique to this case study that would mean similar outcomes would not be seen in other sites? So is there anything unique about this case study that would mean that similar outcomes would not be seen at other sites?
Yeah, there must be some definite limitations and unique of this case study. First of all, it needs some requirements or some fundamental requirements of the industrial level, because it has to use some industrial products like the masonry and the steel bar. It's not quite. It cannot be built totally through manual approach. That is some limitation. And of course, it has some requirements on the soil conditions. It cannot be used everywhere, and if the soil condition cannot meet the requirements of the structure of this structure, they need to add some concrete foundations to strengthen its structure. Yeah.
Okay. And the other thing was, it was based on a statement that you make in your paper. So I'm going to ask a question based on that sentence. And that is, why do you think more workforce was consumed during the reinforcement construction? Because that's a statement you make, but you don't explain, as far as I can see, you don't explain why that's the case.
Yeah. And because actually, in our case, in our studied case, all the all the reinforcement are pre-manufactured in a factory, and it is formed to proper form, so that the workers do not need to cut and form them on site, and that saved many times to build the whole building. And and conventionally, all the workers need to do that things on site, and that causes many time waste on site.
Okay. My final question, and that was based on the photos I saw in the slides there, and I just wondered, and also in terms of what you broke your workforce roles down into, and based on that, I just wondered, can you describe to me the layers of the building envelope? So for instance, are they insulated? You mentioned about cladding, and I could see there was formwork. But what are the layers that build up the envelope of the building?
Actually, the cladding here is not something that works as the isolation layer. It just to use it just use the concrete to, or not, maybe not the concrete, but just the cement to paint on the wall to form a surface. And
okay.
but I use that term here to express that construction process. And actually, the whole building has no additional isolation layers. The masonry it used has a pretty good isolation performance, and it's suitable to use in Jiangsu province, China, where it was built, and it can fulfill the needs of the government to save operational energy during winter and of course summer. Yeah.
Okay. Yeah, no, it's fine. One of the things you just alluded to in your answer there was the uniqueness of this particular part of China. What do your winter temperatures get down to?
The winter temperature is about 0 degree in winter, and or maybe just 2 or 3 degrees minus than 0, and which means that it's not quite freezing.
Right. Okay. Right. Well, thank you very much for answering my questions. Let me just have one final chat, see if there's anybody in the chat, anything been added. So no more questions. So in that case then, I'll use this opportunity to thank you for your responses to my questions, and ask you to step down if you would please. Thank you.
Thank you.
Thank you.
Right. Our final paper of the session is Zahirah, Azizi, and colleagues, I must say, who are based at Newcastle in the UK and also in Malaysia. And they're going to be talking about the affordance of remote working in construction. So let's play our final video of the session.
Flexible working now seems to be the new norm. I, for one, am glad to be living in the 21st century because we have access to so many different technologies that enable remote working to be a lot easier than it could ever be. In fact, for many of us, our phone is like a third hand, and life would be unimaginable without access to the internet. The question is remote working suitable for the likes of the construction industry? Because the construction industry is such a physical-based industry, a lot of its tasks cannot be done remotely. However, we've all been recently forced to work remotely because of the COVID-19 pandemic, and this includes the construction industry. Research has documented several benefits of remote working for the construction industry, which includes improved efficiency, flexibility, and better safety, which are enabled by various technologies that offer capabilities such as automation, cloud computing, and virtual collaboration. In this study, we use the lens of the Affordance Theory to look at the affordances and constraints of remote working in the construction sector. The Affordance Theory provides a lens to understand how technology enhances certain capabilities or offers new capabilities. It's no secret that technology affords us extra capabilities, and we see this discussed in many fields, such as education, but rarely so in the construction context. However, technological affordances is influenced by a variety of factors beyond just the technology infrastructure itself, and this is what we look at in our study. In this paper, we investigate how construction professionals respond to remote working and the factors that affect its efficiency and success. To do this, we used a case study of a large contractor based in the UK. In that company, we surveyed 125 construction professionals involved in project management roles. Each respondent was sent an email inviting them to participate in an online questionnaire. Fortunately, we had the support of the managing director, who helped to encourage participation and to send out little nudges to remind people to do the questionnaire. The data was analysed using the SPSS software, where we took the percentages, frequencies, and standard deviations. Basically, we asked respondents questions on how they perceived remote working, the types of technology infrastructure they had access to, and the challenges that they felt while remote working. And this is what we found. The majority of 82% of respondents said they would like to remote work, but very few actually did. Only 34% worked remotely some of the time, and they did this occasionally when they needed to. And 24% did so consistently at least once a week. We found that 70% of respondents preferred flexible remote working as opposed to full-time remote working, and because it allowed them cost savings, less traveling time, improved focus, and made them happier, while also giving that flexibility of moving back to a physical situation, a physical environment when necessary. 79% of the respondents believe that remote working would help improve work-life balance, and they don't think that it would negatively affect the boundaries between home and work. With the capabilities allowed by technological affordances, 86% said that digitization made information more accessible, and 75% felt more productive when doing remote working. However, 84% of respondents said that they would miss seeing their colleagues, and this would potentially affect work for 48% of respondents who said that the lack of engagement would be a problem. When surveying the main challenges of remote working, 73% felt that collaboration was a major problem. 84% said that they had poor home working arrangements, which affected their ability to work remotely. 48% indicated that 48% said that distractions at home were a real challenge when remote working. So most projects had basic technology such as high-speed broadband and portable technology, but only 60% actually used BIM. Only 38% had automated processes in their projects, and only 4% had utilized robotics. On the contrary, 85% believe that they have enough technologies to allow for successful remote working. So in conclusion, we found a disparity between what people felt about remote working and the actual capabilities they had given the technology infrastructure available. People felt positively about remote working, especially flexible remote working. They do believe that it offers benefits such as improved work-life balance, time and cost savings, easier information access and flexibility. Despite believing that they did have the right technologies to afford remote working, most projects had very limited technology infrastructure. One of the main challenges that they reported was collaboration. This is surprising because research has supported that collaboration would be enhanced with remote working given the technology infrastructure available to allow for virtual collaboration. However, because of the limited technology infrastructure that people actually had access to, collaboration then became a major challenge due to the lack of engagement, lack of communication between colleagues. Home working arrangements and distractions, we found, were challenges that were particular to individual circumstances or specific groups of people. So, for example, people who had to work with children in the home would obviously have more distractions going on at home compared to people who did not have children in the home. Likewise, people who had a proper workspace at home would find home working arrangements less of a challenge for remote working as opposed to people who have to work on their dining table, as I am doing right now. So in essence, while technological affordances do facilitate remote working, it needs to be supported by environmental and social factors of work, in particular those that are related to home working arrangements and distractions, to kind of regulate these factors. So in addition to there being a need for more technological infrastructure to support remote working capabilities, there also needs to be more regulations to support other factors of remote working that are the environmental and social factors. For the construction industry in particular, flexible remote working was one that respondents felt strongly about because it allowed them the flexibility to work from home when it was suitable to do so and to work in the office when they needed to. And also because of the physical nature of construction work, therefore remote working has 3 dimensions to it, which is the physical, technological infrastructure that allow for different capabilities, the social dimension, and also the environmental dimension, in which people would need to be supported with so that they could carry on with remote working more effectively. That was the end of my presentation. I hope that was useful. Thank you for listening.
Okay, thank you very much. Let's just, if we can upgrade. Hopefully we'll be able to, yeah, we can see our delegate. That's great. Okay, so first of all, any questions from delegates first of all? If anyone wants to raise their hand, please do so. And we have a hand raised. Can you see who that is, Emmanuel? It's not showing on my...
Richmond, I'm going to get him up in a second.
Okay.
Richmond, if you could raise your hand bear with me. I'm going to upgrade you. Yeah. Okay, got you. Perfect. So you can turn on your video now.
Thank you very much, Zahirah, for... Is my video on now?
Yes, we can see you now. Yes, perfect. Thank you.
Yeah. Thank you very much, Zahirah, for the presentation. I particularly enjoyed your use of videos and your very high quality graphics. It's such a very interesting thing to see. I have, I think, 2 questions. I'll put them in the chat. I was wondering whether you could talk a bit more about, let me just find the question before I lose my train of thoughts. Yes, so what kind of construction related work did the participants said they would like to work on remotely, given that you rightly mentioned in the introductory section that construction work is very much on-site activity. So what aspects of the construction-related work were your participants interested in working on remotely? That's the first one. And two, I was wondering whether you could also elaborate a bit more on your operational definition of capability in the context of remote working. And then also, I realized you touched a bit more about how different demographic situations, for example, would impact people's ability to work remotely. Is there a way were you able to model the differences in perception about remote working based on, for example, differences in different demographics or also housing conditions, the type of house people live in, if it's a 2-bedroom house, it's a 1-bedroom house, has a living area and all that? Those are the questions I put in there. Thank you.
Thank you, Richmond. Thanks very much. Okay, the first question was around what kind of work it was. We surveyed people who were directly involved in project managing a construction project. So these were construction professionals who were in project management roles. So it's more about people with responsibilities to oversee the implementation of a construction project on site, rather than the people who were actually doing it on field, like the labor, not those. It's just the managers per se. And we already know that these people would be on site occasionally, maybe to check on the site, rather than being on the site to do the work like all the time. So it was more of people just who are involved in project managing the project. So, like architects and engineers, we had quantity surveyors. Those were the people that we focused on in this research. Your second question was around the operational definition of capability. What we looked at was just whether they were comfortable doing remote working, and whether the infrastructure that they had allowed them to do so effectively. I get the fact that there is a bit of a lack of detail in the research in terms of what are those specific items, specific tasks. So we didn't go into that detail. I don't have that information because it wasn't asked. All that we did was we asked what types of infrastructure that you do have, digital infrastructure that you do have, and then what were the challenges that you faced in completing some of these tasks. And those tasks are just like collaboration and communication. They were quite generic in the sense that it didn't dive into, specific technical tasks, if you like, but it was more of, how they used it to kind of engage with their co-workers and implement and continue on with their role in that project managing a project. And your third question was around the demographics thing. So yes, I did touch just a tiny bit on it. And the reason for that is because when we did the survey, we didn't actually ask the respondents on which demographics they belonging to, like if you had children or if you didn't have children. So we didn't, that was lacking in the research, but it did come out as one of the results. And we just kind of realized after that, this is a problem that would be specific to certain groups of people rather than like the whole general. That's why probably the results were mixed. Like some people felt it's not a problem, some people felt it is a problem. And so I guess that was one of the shortages of that research, because we didn't ask for that information at the outset.
Emmanuel and Colin, if you indulge me, I think this is a very interesting study. I've got follow-up questions. As in thinking more broadly, for me, the findings are not particularly new, as it's something that is widely reported in terms of management, because if the person is in a management position, then obviously working remotely wouldn't be something that is new. And therefore, in a sense, this finding reflects what we have seen in other fields, not just construction. Mm-hmm. So I'm just wondering what you think makes this really a major contribution towards our understanding in terms of construction managers' ability to work remotely. Mm-hmm. That right. From the management point of view, I was looking forward to sort of getting some insights whether even these managers have got this technical insight to be able to do some task working remotely. I was wondering, I felt if we had that detail, for example, did they need the training? And also, the ability to even do some of these remote working are not always, they don't always depend on the management, but also the firm itself, the bigger organization they work for, and the kind of organizational structures that have been put in place that can facilitate them being able to work remotely. Or so, to what extent do you think that organizational structure also frame this growing perception or affinity for remote working and either going back to site?
Zahirah, if I could jump in before you talk. So Richmond, good point you've just raised. One of the things that organizational cultures we're talking about, and this is not just construction, even in academia, universities and other places, one of the things that they kept talking when the COVID hit, one of our deans kept talking about how he really supported working from home. Now, before COVID, I had sat in a meeting with him before where he was really against it. So I think the shift is something that we must acknowledge. And this research kind of explores this area where all of a sudden organizational cultures have shifted in a way almost pretending or masking to be open to remote working, but it wasn't really the case. And I think research like this captures where we are now. And if we look back, it was some of these questions that were never asked. Would you be happy to work from home? It was never asked, but all of a sudden we're in a position where people think, yeah, but it's fine, I can work from home, you know? And I think this is one of the things that I liked about this paper. It was capturing that angle that we never actually questioned.
Yeah, thank you. Yeah, that's absolutely right. That's exactly the point I was going to make. The reason why we chose it as a case study, we selected one of the largest tier 1 contractor companies in the UK. So we would think that a large contractor company in the UK would be ready for remote working. But the findings were that even, how many percent was it? A large portion of the respondents had never worked remotely before. But 80% of them said that they would like to work remotely. So there was a difference. There was a stark contrast there. And then when we dived deeper and looked at, what kind of digital infrastructure you had access to, then we found that, they actually had quite limited digital infrastructure. And then while they had to, forced to, during the pandemic, they struggled with these aspects of work. They thought that collaboration was a challenge because communication was maybe sporadic. The communication techniques were different, and so it got quite a bit of getting used to, and they've had kind of isolating, and all these other things were cropping up. So they weren't necessarily ready for remote working, even though it's a large contractor company. And as you've said earlier, it's these questions were never asked. You're right. These questions were never asked, and then now if we do this, and look. You say that you're open for remote working, but actually, no, it's not the case. And I guess this is a starting point to kind of look at next steps of what are the things that people need to kind of support remote working to actually be effective, if that makes sense.
Absolutely. And I think the context that Ima provided sort of settles as I can see the value in the research and the massive contribution it makes. So thank you. Quite exciting. Since it wasn't a question or a subject that was even talked about in the first place, for it to come up in this way, I think I can see now the immense contribution the research makes. Thank you.
Thank you.
Okay, I've got questions, but I'm also conscious of the time that we've now run over slightly, so I'm going to put my questions on hold. So what I would like to do, though, is thank all 3 sets of authors who produced the papers for ARCOM. Particularly the delegates who fielded the questions that we've thrown at you in this session. So thank you to all 3 of our presenters. I hope you continue to enjoy the conference, but for the moment I'll thank you once again and allow you to go and get a comfort break before the next set of presentations begin. Okay, thank you very much for your time.
Thank you, everyone.
Thank you.
Thank you. Bye-bye.
Right.